Okay, section 6.6, solving radical equations. Like I already said, there is very little to try to quote-unquote understand. This is legitimately just algebra skills. Just using algebra skills, solving for x, that's all we're doing. And a tiny, tiny caveat to that, which I'll discuss in just a moment with this. Look, we're trying to solve for x. We're trying to get x by itself. This x is hiding underneath a square root bar. So we know eventually we're going to need that square root bar to go away. Yeah? Okay. I don't know if you can remember way back to solving absolute value equations, which I think was chapter 2. I think it was chapter 2. Remember I told you don't set up the positive and negative until the absolute values are alone? Because that positive and negative case, that was us canceling that structure. In mathematics, we don't cancel a structure, doing operation of both sides. We don't cancel a structure until that structure is alone, which is what you do with absolute value equations. And I'm going to tell you, same thing here. We don't cancel radicals until they're alone. So we need to get that square root bar alone. So what should I do first? Divide by 2. And we know it's division because anytime you have a number pressed against something in algebra, that means times. So we will divide both sides by 2. And that will give me the square root of x plus 1 equals 2. Okay. Next. Square everything. We're going to square both sides because I need the square root bar to disappear. And it is squaring the entire side. If there was more stuff on that side, I'd have to square the entire side, which you'll see happen later on in the notes. But here we're canceling a square root with a square. That gives us x plus 1. And on the right side, we have 4. You subtract 1 from both sides, and you'll be finished. Well, nearly finished. What do you mean, mister? I got an answer. I must be finished. Well, not so much. And here's why. We haven't graphed square root graphs yet, but you have seen them. I've given them to you. Remember when we were restricting the domains of our quadratics in order to find inverse functions? So you've seen square root graphs, and you've seen that they represent only half of a quadratic, right? Okay. That's because if you had the other half, you would have a non-function. You see, square root graphs have restricted domains, which we've been talking about since chapter 1, I think. Talking about, what can you not take the square root of? We've said that a lot this year, right? Okay. Well, because of that, right here in this step, when you canceled this square root bar, you removed all of the domain restrictions that come with that bar. So at the very end, we have to make sure that our answer was even allowed. Did it still work? And you might recall from earlier in the year, it's called an extraneous solution if it doesn't work. So you do algebra to both sides, you cancel some stuff, eventually you get a number answer or 2. It is your job to check them and make sure they actually work. Sometimes everything works, sometimes nothing works, sometimes some of it works. You always check, especially with square roots, because the moment you canceled it, you removed the restriction that says x plus 1 couldn't be negative. That restriction was gone on this step. So take your 3 and make sure it works. 3 plus 1 is 4, the square root of 4 is 2, 2 times 2 is 4. Yay! It works, we did it. So maybe I was just worried for no reason? No, not at all. Because if you solve this algebraically, it will tell you x equals 3. But if you try to use x equals 3, it'll give you back 4 equals negative 4. And no, it doesn't. What I've just written here has no solutions. Why? Because the square root of every single number has one thing in common. It's positive. So you'd have 2 times a positive number cannot equal a negative number. But let me show you that it would give you the same answer. You'd still divide both sides by 2. That wouldn't change. Now you'd have the square root of x plus 1 equals negative 2. Look, we all know that's not possible A square root of something can't be negative 2. But if you weren't paying attention to that and you squared both sides, see, the moment you square both sides, you removed the restrictions. And this is why we always check our answers. Just in case we weren't paying attention on this step and seeing that that's not possible. Okay? Always checking your answers. See how easy it was for me to come up with an answer that with a question, that had no solutions? I mean, like that, I did it. Just cluing you into the kind of things you can expect for your test. I expect you checking your answers. How do you feel about isolating square roots and squaring both sides and then checking your answers? Not too bad, right? A little bit of sad mep for you. Put them down in reverse order, just get next by itself. Okay. Small early Christmas gift for you right here. Cube roots cannot ever make extraneous solutions. They can't. It's not possible. You don't know why yet because we haven't graphed them yet. We'll be doing that tomorrow. But for now, I'm telling you, cube roots, all you have to do is make sure you didn't goof up the math as you were going through it. They can never give you an extraneous solution. Yay! I'll still check my answers to make sure I did the math right. But it's not because I'm concerned that it's extraneous. Just like square roots, we don't cancel a cube root until it's alone. I'm going to have to move that -1. So I have to add 1 to both sides. We cancel square roots with squares. How do we cancel third roots? Cubes, third powers. Yeah, third powers. Raise both sides to the third power. 3 to the third is 27. And now it's an Algebra 1 question. Add 9 to both sides. Uh-oh, is my green pen dying? Divide both sides by 2. I ran out of vertical space. Crud. $18. I'm pretty confident in my algebra abilities that I didn't make any mistakes, but just in case, I'm going to check. 2 times 18 is 36. 36 minus 9 is 27. The cube root of 27 is 3, and 3 minus 1 is definitely 2. So it works. Again, I wasn't concerned of extraneous solutions, not possible with cube roots. You guys all right with that? When I say not possible with cube roots, I mean when you have like cube roots equal to a number or something like that. I mean, it's extremely possible for me to design, and I won't do it to you, oh my goodness, but it's extremely possible for me to design like a cube root being set equal to a square root and they have no solutions, but I have absolutely no reason to do that to you. None at all. So I won't. Okay? Now that I've said it, I might make one for myself because I'm a nerd and that sounds fun, but I won't do it to you. Questions, comments, concerns on what I did right there? Or still pretty easy? Still pretty easy? Okay. Still very easy? Okay. All right. Okay. You can't cancel a square root until it's alone. So, get it alone. I'm going to add this square root to both sides. Go Gators. It gives me 2x plus 5 equals, square root of 2x plus 5 equals square root of x plus 7. Canceling square roots the same way we did before. Square both sides now. As it turns out, both of these square roots are alone. Once again, Algebra 1 question. Let me get all my x's on one side and all my non-x's on the other. So I'll bring the x's to the left, and I'll subtract this 5 to the right, giving me x equals 2. Now, because I had square root bars, I'm concerned that extraneous solutions are possible. Therefore, I check my answer to make sure it works. Take x equals 2. 2 times 2 is 4, and 4 plus 5 is 9. This says square root of 9, which is 3. 2 plus 7 is 9. This is square root of 9, which is 3. So if you drop in 2, you get 3 minus 3 equals 0. So again, it worked just fine, didn't it? Yay! So I wonder how hard it would be for me to change it slightly and write a question that has no solutions. Well, allow me to show you how easy it is. There. That has no solutions. And it's pretty obvious why. The number in here and the number in here, they could end up having the same value, but the only way that I could add these two things and get 0 is if either they're both 0 or if one of them was negative. And that's impossible. But I'll tell you this, if you attempt the algebra, it will tell you x equals 2. And if you try to use 2, it'll say 3 plus 3 equals 0. Let me show you why 2 is the answer you get. That doesn't work. Subtract this to that side, and what you get is this. But the moment you square both sides, you squared a negative on the right side, which turns positive and gets you to here. So x equals 2 again. But x equals 2 fails. I'm hoping you're starting to see how important it is to check your answers. What do you think? See, it's just algebra. It's all it is. We're moving stuff around and we're canceling stuff. Nothing to really even understand. Only thing you have to make sure you do is make sure the answer works. Cool? Okay. Now, is it possible for me to add or subtract 2 cube roots and get 0? Yes, absolutely is. How come? Because cube roots can be positive or negative. That's why. That's one of the reasons why they don't generate extraneous solutions very often. In fact, you in this course will never see it happen. Like I said, I'd have to go out of my way to produce something using graphing skills that would give me extraneous solutions. And I won't do that to my students. It's not fair. I wouldn't do it to my pre-calc students. It's not fair. It's just mean is what it is. And I'm contrary to what my wife and children think. I'm not just mean for the heck of it. Okay. There's always a reason. Crickets. Okay, that's all right. I'll save the good material for the laughing classes. Alrighty. Just like before, don't cancel a cube root until it's alone. I'm going to add this 2 root stuff to the right. Just trying to figure out what colors I want to use. Go back to OG. Let's add that to both sides. I try not to make my notes redundant because, I don't have a whole lot of time to be wasting doing the exact same kinds of skills over and over and over again. So then why is this example in here? I mean, you just saw what happens when you have a square root equal to a square root, right? It should work relatively the same, right? This example is in these notes for a very special reason. Do you think you see what it is? Anybody? That way I could prove that I wasn't sitting alone when I recorded these notes. Thomas, what do you think?
The 2 gets to the power 3.
It's because there's a 2 sitting there. And when I raise both sides to the 3rd power, that 2 gets that 3rd power also. And that's what makes this question special. But let's be really specific here, though. It's because this is a product to a power. And if you recall back to when we first started this chapter, when we reviewed the exponent rules, I said something like a times b raised to some power is the product of the numbers raised to the power. It says when you raise a product to a power, both objects get the power. That means this cube root gets the power, and so does the 2. They both get the exponent. On the left, so I'll show one extra step. On the left, I have 2x plus 5. On the right, I have 2 to the 3rd. And I have x minus 4. And the parentheses around the x minus 4 are a necessary structure. If you don't put those parentheses around the x minus 4, you are going to get the wrong answer. And you know me, that wrong answer is on my test. You don't want to be that person saying, every answer I found was there, how did I fail? It's because you're making common student mistakes. That's how. So we're going to distribute that 8. This is distribution. This is not. This is application, applying the power to the 3 and the radical. This is actually distributing. If I can avoid dividing by negatives, I do. I just don't like to divide by negative because then I have to remember to change signs and things like that. So because of that, I typically just move the x's to whatever side I need to avoid the negatives. We'll get the same answer if you already subtracted 8x from both sides. I just don't want to have to do that. It's going to give me 37 equals 6x. So dividing both sides by 6 gets you a not very pretty fraction. And this is one of those times where you will be thankful that you were methodical and careful in your algebra. That way you don't have to try to test 37 over 6 to guarantee to yourself that it works, because it's not pretty. It works. These are cube roots. It's not extraneous. But I don't want to. I don't want to have to figure out what, 2 times 37 over 6. Okay, well that's 37 over 3 and 37 over 3 plus 5. I don't know. 15 and 37, 52 over 3, which is, what's 52 over 3? It's not, you can't divide 52 by 3, can you? No, so it's the cube root of 52 over 3. And then here, 37 over 6 minus 4, what's 37 minus 24? 13 over 6. But then this 2 came out, so it could have been an 8 inside, and 8 times 13 over 6. It's just not pretty. It's no fun. So if you've got a cube root, know that you don't have to worry about extraneous, and be very methodical in case your answer is yucky. Okay? That answer works. It does work. 8 times 13 over 6 is the same as whatever the heck I said was inside there. They're the same. What? This says solving a radical equation. Okay. Let me remind you. Fractional exponents can be written as radicals with powers, or radicals with powers inside them, right? Yes, Mr. Brown. But remember, we're not going to try to cancel a structure until it's alone. Allow me to write this as a radical equation. The over 4 power is the same as saying the fourth root. There we go. So what I have here is the 4th root of quantity 2x cubed equaling 8. So how do we cancel 4th roots? Somebody shout it out. Just shout it. Come on, come on. Yeah, 4th power. Quick, nerds. What's 8 to the 4th? No calculators. That's what I thought. I wish Brody was here. He would have known. No, 4096, because of that stupid game he plays on the phone where it's like called 1024 or 2048 or something. Well, 8 to the 4th power is 4096. It's a power of 2. He might have known. But here's the thing. How many people in the room besides me knew that? None. And that's okay because that's not what I expect you to do. So if I'm not going to raise both sides to the 4th power, what could I have done instead? Ooh, yes, I don't want to do that though, for a reason that I'm going to show you in a minute. But yes, Megan said I could use the reciprocal power on both sides, raise both sides to the 4th third. She's right. I don't want to do it that way though, because I'm trying to remind you of something. Barry, what is it? Yes. So what Barry said was I could cube root both sides because he remembers that the order of exponentiation doesn't matter. That 3 does not need to be on the inside of the radical. It could be on the outside of the radical. Then, like you said, cube root both sides. Megan, what you said works perfectly. But I'm going to caution you about something that's going to occur in the next example. Okay. What's it give me? It gives me the 4th root of 2x equaling 2, because that's the cube root of 8. Now we can safely and easily raise both sides to the 4th power. And divide both sides by 2 to get x equals 8. You should be in the habit of checking your answers. But it will require you to know how to evaluate numbers raised to fraction powers, which you need to know for your test anyway because it was on the last test you just took. So you might as well know. Let's take this x equals 8 and bring it up here. 2 times 8 is 16. I'm going to make the number small by going with the 4th root of 16, 2. 2 to the 3rd power, 8. 8 plus 2, 10. It works. Yay! It works. A moment ago, I told you that I don't like to have examples that are redundant. I try to make it so that every example was there for a very specific reason. And as it turns out, this next example is on here for 2 specific reasons. Can anybody see one thing that would separate it from the one I just did? Ilya? I think he's saying that the top is not odd. That's one of the things I needed you to see. Brock?
There's no parentheses around the 10. I'll do it the whole thing.
And there's no parentheses around the 5. Those are the 2 very specific things you needed to see about this example. In this example, the 2 was being bossed around by this exponent. In this example, the 5 is not. So the 5 will go away before I'll deal with the exponent. So first, let's add 4 to both sides. Because there's no parentheses, the 5 can be divided away. Now, a moment ago, Megan, you said you could raise both sides to the reciprocal power. You said 4 thirds power. And yes, absolutely, because when you raise a power to a power, you multiply, and reciprocal fractions multiply to 1 every single time, which is actually why square roots cancel squares, because 2 and 1/2 powers are reciprocals. So it works perfectly. But Ilya pointed out that the numerator is even. Let's pretend for a moment it didn't say over 3. I'm just going to cover it. There is no divide by 3. How do I isolate x here? What operation would get this x alone if there was no over 3?
Raising each side to the power of 1/2.
Well, don't overthink it. What cancels squares? Square roots. Yes, what you said, the 1/2 power is the square root. But you take the square root of both sides, right? And you would then be canceling an even power with an even root. Which does what? Absolute values. So you would have the absolute value of x equals 3, which means x would be plus or minus 3. And Megan, that wouldn't have been an issue here because the numerator was odd. Because the power you're canceling is the third power. The power you're canceling here is the second power. So now the dirty little secret has finally come out. It's not when you cancel an even power with an even root. It's when you cancel an even numerator power with an even root. Because technically x squared has a fraction exponent. It's 2 over 1. So if you ever have a fractional exponent or any exponent, and the top of that fraction is even, like I said, it could be the same as saying x squared because that's 2 over 1. You have to worry about the absolute value signs, which means you're going to end up with a plus or a minus. And the proof of that is if we write this as the cube root quantity squared. Could I just raise both sides to the 3/2? Yes. But if you do that, there's a very good chance you might miss the fact that you needed absolute value bars. Now, if you see when it's going to happen, and you know you're not going to get caught by it, by all means, do that, because it's more efficient. But if you're concerned that you might miss it, and you don't want to get half credit because you know I'm going to put that on my test, and that's going to be worth half credit, you know me, you know that's going to happen. What I would suggest you do then is write it in radical format. Actually, it doesn't even matter if the 2 is on the inside or outside. You know what? I'll put on the inside. Oh, that's why I didn't put on the inside. Crud. It's because 9 to the 3rd power is a big number. I should have trusted my gut. We cancel squares with square roots, right? There is you canceling an even power with an even root. That creates that plus or minus. That is a result of the absolute value bars. So I'm bypassing the absolute value bars going directly to plus or minus because that would have been the result of the bars anyway. Right here. Canceling an even power with an even root created that plus or minus because it should have been absolute value. Now you just raise both sides to the 3rd power and you are finished. 3 to the 3rd is positive 27. Negative 3 to the 3rd is negative 27. Yeah, x equals plus or minus 27. And I feel so bad because in period 1, I just raised both sides to the 3/2 and I forgot that it was going to create a plus or a minus. So they didn't see that today. I'm going to have to send out a remind telling first period to watch this video so they could see this question done properly. Do you have questions for me on how to recognize when the plus or minus is going to be necessary? Yes?
How do we, what's the clear factor to understand whether it's going to be a plus or minus or an absolute value bar?
Oh, okay. So the plus or minus is occurring because of the absolute value bars. So if I just asked you to simplify an expression, there was no way to solve for a variable of any kind. If I just said, hey, what is the square root of x squared? And I just wrote it like that, the answer is this. But if I set it equal to a number, those absolute value bars create a plus or minus on the other side of the equation. So if I'm asking you to solve for x, what you're looking for is, I'm pointing at something you can't see. You're looking for an even numerator exponent. And if you see that, you know there's a plus or minus somewhere. Cool? Okay. Yes, sir.
So whenever an even numerator gets canceled by an even root, that means there's going to be plus or minus?
Yes, because what you've done is you've now canceled an even power with an even root. It's canceling even powers that's dangerous. I mean, if you come back to the front, you see here I canceled an even root with an even power. This order doesn't create a plus or a minus because the only way this works is if 2x plus 5 was positive anyway. You see? But if it's like this, oh, well, x could have been negative, and you never would have had a problem because the first thing you would have done is squared it. And that's the difference. So it's just when you're canceling that even power that is going to be an issue. And even then, it's if you cancel the even power and the result was odd. You know? So it's just something we watch out for. Now for the more interesting questions. You may notice that the title has not changed, solving a radical equation. That is because the 1/2 power is a radical. Which one? What radical is that? The square root. Why is it I can only get like 3 or 4 of the guys in the room to talk to me and occasionally Megan? Come on. I'm just going to start calling people out. I'm going to look for earbuds and start shouting at those girls. Yeah, that's right. Like I didn't notice. Let's say you didn't want to think about what the possible restrictions were at the very beginning of the question. That's fine. What you should notice, though, is this is a square root equation, and you should immediately think, I'm going to have to check my answers at the end. That's always the first thought, okay? Okay. First, absolute value bars. Square root bar is alone. Cancel it. Deuces. Oh, literally, it's a 2. Ha. Square both sides. X plus 6 equals x squared. I have x's and x squareds. How do I solve that kind of setup? We spent an entire chapter working on these. Man, you guys can make me say the F word. Factor, there it is. That's the F word. When you have x's and x squareds, your job is get everything to one side and factor. One of my favorite F words. Sure. I like fond, flamboyant, frond, fudge. What are some other F words that are fun? Fun. There you go. Fondue. Fondant. Things like that. Fail. Got him. Oops. There. Oh, we like this kind of factoring question because there's no number in front of x squared. When there's no number in front of x squared, you're finished factoring. That's a lot of F words. You're finished factoring when you figure out which two numbers multiply to -6 and add to -1. -3 and +2. Barry is on it today. Thank God. Nobody else is talking to me. Okay. Because it's set equal to 0, we can easily see what our solutions are. 3 and -2. We always check our solutions in the original setup. The original setup is what I've written in black. I'm going to check it here. Remember, the red stuff's not there. I'm going to check it in the black statement to make sure it works. So let's take this x equals 3 and let's see what's up. 3 plus 6 is 9 and the square root of 9 is 3. So putting a 3 here and here says 3 equals 3. That works. Yay, x equals 3 is a solution. Now let's check -2. -2 plus 6 is 4. And the square root of 4 is 2. Putting a -2 here and here says 2 equals -2. 2 doesn't equal -2. That answer is extraneous. It didn't work. Is it possible to write a question with 2 real answers that work? Of course it is. Very easy, actually. Not difficult at all. This one just happens to not have 2 working answers. Yes, sir?
Just checking in black just make it simpler.
Yeah, I just wrote it with a square root bar instead of the 1/2 power. Just to make my life easier, yeah. Because I know people recognize it faster, you know. If I say, hey, what's 9 to the 1/2 power, and make you think longer than if I say, what's the square root of 9? Even though it means the same thing. So is it because this was negative that I instantly knew it wasn't going to work? Not at all. Not at all, not at all. Let me prove a point to you, just like I did on the front. If I rewrote this equation, and instead of saying equals x, it says equals negative x, then the only answer that works is negative 2. And 3 fails. If it said equals negative x, and you plug in 3 right here, it'll say 3 equals negative 3, which is false. But if you plug in negative 2, it'll say 2 equals 2, if I change that to negative x. So again, it's not because this was positive and this was negative. It's because this worked and this didn't. Okay? Could I have 2 positive answers that work? Yes. 2 negative answers that work? Yes. 1 and 1 that both work? Yes. 1 and 1 where both fails? Yes. 1 and 1 where they both fail? Absolutely. 2 positive that fail? Yes. 2 negative that fail? Yes. All those things are possible. We just check them and make sure it works. Cool with that? And the most difficult that I'm going to ask you to pull off is here. You can't cancel a square root until it's alone. Move the 4. Square roots alone. Cancel it. Square both sides. On the left side, I'm going to have 2x plus 7. And let's just pretend I have a student in the room whose Algebra 1 skills are not good. Tell me what I'm worried that they're going to write on the right side. It's definitely wrong. What am I worried I'm going to see? X squared plus or minus 16. Both of them are wrong. You can't square this x and square this negative 4. You can't do that. That exponent of 2 says there's a pair of these x minus 4s sitting next to each other. And you're going to have to distribute. When you do, you get 2x plus 7 equals x squared, after combining like terms, minus 8x plus 16. Just so you know, similar to this one, if you had forgotten to write these parentheses and you just wrote 8x minus 4, I will make sure that wrong answer is waiting for you. If you write x squared plus 16, and solve, I'll make sure that answer is waiting for you. If you do x squared minus 16 and solve, I'll make sure that answer is waiting for you. I will do it. Because it tells me exactly what mistakes you're making. And then I can have an idea, at least, of what to address when you come ask for help. Because I have x's and x squareds, I need to get everything to one side, and I want my x squareds to stay positive. I'm not going to try to factor with a negative leading coefficient, so I'll subtract 6x and 2x, excuse me. Subtract 2x and 7 from both sides. I have run myself out of vertical space, though. All right. And it factors. There are 2 numbers that multiply to 9 and add to negative 10. Negative 1 and negative 9. There it is. So we can see our 2 solutions. And notice both solutions are positive. Let's give them a try. We take the x equals 1, and we plug it in for both x's. 2 times 1 is 2, and 2 plus 7 is 9. Square root of 9 is 3. 3 plus 4 is 7. So if I put a 1 here and here, it says 7 equals 1. No, it doesn't. Now let's try the 9, because there's no guarantees that anything works. Let's try the 9. 2 times 9 is 18, and 18 plus 7 is 25, and square root of 25 is 5. 5 plus 4 is equal to 9. So that one works just fine. Could I have written the question so that it had no real solutions? Absolutely. I just chose to let you have one that works. And that's the whole lesson. I hope you think like I do that it's really not that hard. Hardest thing about it? Watch out for those. You got this, nerds.